Hello ladies and gentlemen, third time's a charm. I'm trying to do a tutorial, just a quick tutorial based on the serialization and deserialization of data, which is a fancy way of saying saving a game basically. So you're going to save it, you're going to serialize it, which encrypts it so it can't be messed with, altered, and then you're going to save it to a file, and then later we'll load that file and then deserialize it so we can use it in the game itself. So that's what these three buttons are. You got save data, load data, and read data. Ignore everything else. That's just for my current game. I just couldn't be bothered to make a new scene. We won't get into the user. This is what the this is what we're actually doing it on. So there's a data manager user, something that will actually use the data, because the data manager itself should never be instantiated. I've just had it as a set of static methods. So it can be called from anywhere. Anyone can call save, like datamanager.save or datamanager.load, and it will just load the file, deserialize it, and put all the data where it needs to go. So we'll get into that. We don't need to worry about the user so far. This just basically covers the buttons. So you've got a button to load the data, you've got a button to save the data. Well, this actually sets and saves the data. In reality, you'd have something like this. So you'd have a button, you'd have something that sets data, and then you'd have a button to save the data. Or, well, it doesn't have to be a button, obviously. Like if you exit out of a menu, you might save the data. If you finish a level, you might save the data, that kind of thing. And then we've got just a little debug thing to read the data. So it just says, is the player alive? And returns this boolean. Says the name, says his current level is blah, 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 etc. But we'll get into all this. We'll do a quick rundown. We've got a blank document for the data manager itself, and we'll get right into it, starting with, I think, the file name. So everything needs a file name, obviously, if you're going to be editing a file, and I find it convenient to have it as a constant. I've also done it as not a constant if you have a game with multiple save files. So I've got the setting data is going to be a constant because you don't want multiple settings profiles. You may do, but generally you don't. But you might want multiple game data files, right, if you have different save slots. So it doesn't have to be a constant. But for the settings itself, I've made it a constant. So public constant string, settings data file name, and dash, that's important, so it goes, because we're going to be adding a big file path, I'll show you that in a second. Settings data tutorial, and I've done .gd for game data. It doesn't actually have to, that's just it, whatever you want to call it, dot whatever. And we'll get straight into, I think, the load function first, because that's the most complicated one. It's not even that complicated, but I'll throw it in there. I'll get the load data and the load actual. In case you're wondering why I have this separate and I just haven't copied this here, is because I've set it up in a way that this can be inherited from. You never actually use this data manager class. You'll use a whatever your game name is, data manager. So you'll inherit from this class, and then you can have a load settings function and a load game function, and it just makes it more versatile. This way you can have a load actual function implemented in multiple different functions. I'm saying functions a lot. So getting into load settings, first we create a settings data file, and that's the most important thing. This is where the beauty of the system shines, in my opinion, and I'll create that now. So we want a serializable system.serializable struct. System.serializable obviously means that you can serialize it, as I said, and here is where all the data you use would be stored. And it seems quite straightforward right now. You're like, oh, it's just a copy of these three that we're using up here. But in reality, you can put anything in here. So it could have these three, then it could have data for totally different method. Like this could be player data, and you could even make this a struct, really. You could have this as a public struct player data, and then instead of having these three, just say it would take in that struct of player data, and then you'd save and load that struct into this user. And you could have a struct for enemy data, world data. You can even have a list of those structs. Honestly, it's endless. It's very, very versatile. I've used it for several years for everything and never ran into any hiccups of, oh, I wish this system could be expanded here. So first thing we do after creating a place to hold the data that we're loading is to load the file itself, but first we have to see if it exists. So using system.io, we're going to do file.exists, And this here interesting little thing there before the settings data file name is the application.persistent data path. And what this is a changing path depending on which platform you're running off. So if you're using Apple, it'll be different. If you're using Windows or Android, it'll be different. But this is basically where you want to save stuff. This is a persistent data path, so it won't be messed with by anything else. It's a good place to store data. Plus dash, so it'll create like a, you know, I don't have to explain how navigating files works. So that's why you need the dash there, because it adds all together. And then it'll just say, give it a little debug loading, and then we'll get into the load actual settings data, blah, 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 down here. But before we do that, if it doesn't exist, if the file is not there, then instead of loading the data, you want to create the data. Create data. I don't know what I put make. And this basically just fills up the settings data that we've made up there. So it has to put something into every slot that you created, and this will be the default data that's loaded, so you don't get any null reference exceptions, essentially. There wouldn't be any here, obviously, because these all have default values. And then you use it. So this is where you would occupy it. Here you might run into a problem with the find object of type data manager tutorial user. So if the user doesn't exist in the scene, obviously you're going to have an error. So that's the only place that might trip you up. So you should never destroy the user, basically, no matter what it is. So obviously you don't want to store enemy data on a single enemy itself. If you want to have loads of different enemies, you'll have like an enemy manager, and that'll store the data for the enemies that it spawns, that kind of thing. You never want to destroy the things that use the data, because that's what you're finding, that's what you're putting the data into. If you don't want to do that, if you have something else, then how do I explain it? If you have something that you don't want to load the entire data into, you can either have multiple load functions, I said. So I have load settings here, you might have load game, and you can narrow that down further. Or you can do what I did, which is make preferences, because Unity has its own get and set pref. You might want to look into that. I'm not going to re-explain it here, but I have remade that, and I'll cover that briefly at the end. And that allows you to just do one-offs. So I have something like music volume, and whenever I set the music volume, I don't go through the entire save and load settings feature. I just save and load that one preference, that music volume preference. 7 minutes, not too bad. So this just finds the user and then sets all the data up there, fills it in. So I'll go back up here to the load actual function, and as you can see, it has a return type of T. I forget what this is called. It's not enumerable. That's something else. I'm thinking those are words coming to my head. It's basically a return type of anything. Nullable? No, that's not it. Just load random keywords coming into my head. So it can basically return any type. So here we've specified settings data as the type it's going to return, and we're basically promising it that, yeah, this file is going to contain settings data. That is another part that might trip you up. You might get that error if you have the file names mixed up, or if you've saved something incorrectly before. It's going to try and deserialize the wrong file format. So the first thing you do is open the binary formatter. Obviously we need to again include that using system.serialization.formatters.binary, and we're going to open the file. So file stream file equals, and then you're going to open that file, the same file we have up here. Maybe I could just make this one string without having to do it twice, but who knows. And then you're going to open that. It's file mode.open, and then you're going to populate the data. So you're going to say T save data. So this is just the name of T, which, as we specified here, is going to be a settings data. And you're going to use our binary formatter that we've just made there, and deserialize the file and cast it as T, which cast it as settings data. Then don't forget to close the file, because I think it just continually uses up memory if you have that file open, and then return that type. So there's a lot going on there, but you don't really need to know what it's doing. You just have to trust that it works. It's just a binary formatter, basically encrypts and decrypts the data. The file stream opens the file, and then so you deserialize the file into a save data, and then you close it, and you're good to go. down here, it uses that data that we saved.
Battle wave after wave of enemies while upgrading your defenses, all in the hopes of finding a new home for humanity above the stars.
No one will sponsor me, so I've got to plug in my own 15-second ads. Check it out, links below. But the saving itself is also something that we need to get into. It's quite similar. I'll put it up here and get into it, and I'll make the save actual function. Again, this is so you can have multiple different things calling the save actual file, and you can save different types. It doesn't have to be this settings data struct. You can save whatever you'd like. And much in the same way, first thing we do is create a settings data file to hold it, just temporarily. And then we'll say, instead of finding the object, finding the user or users, whatever's using the data, and putting the data into that, we're going to take the data out of that. So we're going to find the user and say, the settings data we've just made, the player alive is equal to whether or not the player is alive in the user, blah blah, the name, the level, etc. And then we'll get to the save actual, which again is even easier. Same thing, binary formatter, but this time you create the file instead of opening the file, and feed in the same name. Obviously we don't have to check if file exists for saving, because if sometimes it won't, and the first save that file won't exist. It doesn't matter. File create, if it does exist, if this does exist, if this application.persistent data path plus saved name is there, it doesn't matter, it'll just overwrite it. And then once we've created that file, we're going to serialize the saved data into the file and then close the file. So not too complicated again. I think the saving's a lot easier than the loading. The loading's a bit more finicky. And then finally, just in case you need it, it's nice to see, we're going to drag in this delete file. And I believe I used that on the other thing, yeah. So a delete file just takes in the file name, and then if it exists, if it doesn't exist, obviously you don't have to delete it, but if it does exist, then file.delete that, and then just quit the application. You don't actually need that to be there. I don't know why I have it in. I have it on there on my actual game. And there, now our user will work. So we have a button for loading the data, which obviously just loads the settings it says. A button to save the data, which first sets some data. Maybe I should split these up to make it a bit clearer. So we'll say the name of the player doesn't need to change. We'll set his level to 2. Maybe we can set the default level to 1. So instead of calling him default player, we'll call him the hero. So this is all the default data when you create data. So we'll level him up to 2. We'll kill him. We'll level him up to 2. So maybe he got in a fight and he died, but he got some XP. And his name will stay the same. And then you can read the data, and we'll show you how that works. The clear data settings literally just calls that delete file with the file name, so it clears the clears this file, deletes that file. And I've made this a context menu, so because I was lazy to make another button, so I can just right click from the script itself, the user, and press clear settings. You'll see it clears it. So if you press read data first without loading any data, you'll just get the default values, false, an empty string, and 0. If we press load data, you'll see it triggers that creating data script here. Instead of going to, I hope the text is big enough. I'm using an Ultra HD monitor. So we created data because the file didn't exist, otherwise we would load data, and then we set the default values, and we filled in the default values to where they needed to go. The user, player alive, name, level came from what we just set there. You could probably, no, sorry, I was going to say you probably put this up there, but no, because this is where we're using it even if it loads. So now if we read, these are the default values we've put. Is he alive? Yes, true. His name is the hero and his level is 1, so that's the default values. But that won't save because we haven't saved it. And we can show that by closing it and playing it again. And if we press read, it's the same. And if we press load, you'll see again it creates the data because we didn't save it. But now, We press save data and it'll say saving data. And now if we press play, and note that we didn't change the name, so the name was already set on creation. Now if we press load, or load data instead of creating the data, now if we read it, the player is dead because we killed him. His name is still the hero as it was by default when we press the load data, and his level is 2 because we leveled him up. So yeah, now every time you play, you can just straight away. Usually you do this on like the awake. As soon as you get into the game, you'd load the data, and then it would be there to use every time.
Hey, it's Armand from the future. I didn't do a very good job explaining the preference system, so I'll go over there now. So the Unity preference system is quite straightforward. It lets you basically just say get or set pref, and then you put a string in for the name of the preference, and then you get or set a value to it. But I wasn't too happy with it, because if you want to get a pref that doesn't exist, then it comes up with loads of errors. So making a custom one allows me to combine this key exists method into the get pref itself. So now we have, instead of just having a key, we have a key and a default value, and we can also include a string for a file name, but that just defaults to the setting prefs file name, which I've set up here, another constant string. But if you have game prefs, I guess you could pass that in if you want different kinds of preferences. So like I have a clear settings here, and it clears the settings data and settings prefs. But anyway, first things first, it's much like the settings data struct up here. We want to save a type of data, but the type of data we have is this. So it's a dictionary of strings and objects. So it's basically just a dictionary of objects to store any kind of data. So you can put anything into this. You can put ints, you can even put like this probably, I believe. And the first thing we do after getting a place to store it, we do that here. We just call it dict. And then if it exists, blah blah blah, load actual into it. And if it contains the key that we pass in, so say we're looking for music volume and we see get pref of type int music, or type float I guess, music volume, and it'll say oh yeah, there's a music volume key, we're gonna return what value there is at that key, and obviously cast as an integer. So it's essentially the same thing we've done before. And if not, so this is why I prefer doing it this way. If the key doesn't exist, if we try to load it, if we try to load it and there's no key there, then just return the default value that we've passed into this function. So if I say get music volume 1, and I've never actually set the music volume, say it's the first load, it'll just return 1. But also it'll set the preference in that case as well, so it'll save it at the same time, which is nice. The set pref is the same thing, but on the other side, again, you create a dictionary of string objects, so a dictionary of objects. If it exists, load it in. And then because obviously you don't want to just make the dictionary and then save it. You want to load the dictionary, change it here, and then save it, because otherwise you'll only be saving that one value. So you change the value, and then you overwrite the file, and that's it. That's done. That should work to get and set prefs as soon as you want. The way you call it is just, so you'd be like get, well, you can actually just see it there. So yeah, you'd set pref, and if you wanted a certain type, you could do it. You could specify everything. So say I wanted to set a preference of type int, and I want the key to be player health, and I want the default value to be 100. I want the string file name to be game data.gd, and don't forget the dash. So yeah, that should work, and yeah, hopefully this tutorial will help people. I hope I haven't forgotten anything. Thanks a lot for watching, and have a great day.